Hi everyone, Mr. Ince here. This video is going to be for Valhalla Geometry Notes on Tuesday, October 25th. First, make sure that you're using your Unit 4 notes packet. This may seem a little bit out of order, but today we're going to be doing the first section from Unit 4, and then starting tomorrow on Wednesday, we'll make sure that we get back to our Unit 3B material. Alright, this first section deals with classifying triangles. Now make sure that at any point during this video you are getting down the same notes that we do, and remember you can always pause or rewind to make sure that things are going at a pace that works for you. When I think about the word classifying, another way of thinking about that is, hey, give it a name or identify that triangle in a more specific way based on certain details that it has. There's a couple different ways of doing this. The first way is going to be to classify the triangle based on the angles that they have. There's 4 different options when it comes to this. If a triangle has 3 different acute angles, 1, 2, and 3, they're all less than 90 degrees each, you know that that's going to be called an acute triangle. I'm just going to be using the triangle symbol right here to save a little bit of handwriting. The second one, if you see 3 congruent acute angles, you can notice that by the 3 single arcs that they have. That indicates that those angles are all the same size. That's going to be referred to as an equiangular triangle. Kind of a funny word. Now, side note, one thing for you to think about is we know that all triangles contain 180 degrees. And if all 3 are the same size, you could divide that by 3, and we know that this type of triangle is going to have 60-degree angles for all 3. Next up, this one's going to be a right triangle, and we know that because of this clue right here. It just contains one 90-degree angle, and therefore it's going to be referred to as a right triangle. And then finally, the one over here on the right is going to be an obtuse triangle. Now, the way that we know that it's an obtuse triangle is that if there's one angle that is above or greater than 90 degrees, in this case, this angle is our clue. And once again, that's one angle greater than 90. Moving on. These first examples ask us to classify the triangles by angles. So we have those 4 options that we did up above. First thing you should do is look for any clues. To me, this looks like a clue right here. I see a 90-degree angle, which instantly tells me this is going to be a right triangle. Number 2. Looking around at these angles, I see a 47 and I see a 30. I know that both of those are acute, but it's this one right here that makes the decision for me. That's an obtuse angle, and therefore this is an obtuse triangle. This third one here, I notice that all 3 of my angles are less than 90. Therefore, this has to be an acute triangle. It's a cute little fella. Next set of examples. It says to use the figure to classify keywords in the directions, classify each triangle by its angle measures. Okay, let's see here. Why don't you go ahead and pause and see if you can get the next 3 on your own, and then check back in once you have your answers to see how you did. When I look at triangle DFG, that means I'm starting from point D through F and through G. I notice that that's actually referring to the largest one. If I were to draw that separately, just so that I get a sense of which angles I'm dealing with, this one was 54, this one contained the right angle, and then this angle here was 36. This angle right here is my clue that this is going to be a right triangle. Triangle DEG means I'm starting at D, I go to E, and then I finally end up at G. Let's draw that one a little bit separate. Looks a little something like this. This angle is 54. This angle is 68. And this angle is currently unknown. Now we can figure out how to do this. There's a way to uncover this one. We know that in a triangle all 3 angles add up to 180 degrees. So if I know two of them, I can always find the third. So to learn about this angle right here, just to make sure that my decision is correct, I'm going to do 54 plus 68, which equals, let's see here, that's 110 plus 12, that's 122. And then I will take that 122 away from my 180, which means that I'm left with a 58-degree angle right here. So now that I see that I have angles of 58, 54, and 68, all three of them are acute, and therefore this is an acute triangle. Finally, triangle EFG, that's from E to F to G. I can see a 32 and a 36, and that means the only one that I need to learn about is this one right here. Now I'm going to rely on previous things that we've discussed. It looks like this angle of 68 here, and this other angle that stems from the vertex point of E. Together they make a straight line, also known as a linear pair, also known as two angles that are supplementary. So if I want to know what this one is exactly, just to make sure that I'm making the best decision, I can take 68 away from 180 degrees, and that leaves me with 112 degrees. And then I tell myself, hey now, that is an obtuse angle, and therefore I'm going to label triangle EFG as an obtuse triangle. And I'm feeling confident because I have all the values to back it up. Now switching gears a little bit, we're still going to be classifying triangles, which again means just identifying them based on their details. But this time we're going to be doing it by sides. If you have three congruent sides, which our clue is that we have a single dash, and single dash. That means that all three of those sides are the same lengths, and therefore this is referred to as an equilateral triangle. You can kind of think that equa sounds like equal, and all three of those sides are equal in size. Next one, where at least two congruent sides are present. Our clue right here is we have a double dash and a double dash, not to be confused with the classic Mario Kart game called Double Dash. But if you have two sides that are the same length, we are dealing with what's called an isosceles triangle. And then our third name when it comes to classifying by sides is where you have no congruent sides. All three are different. We have no evidence that states that any of these are the same, and this is referred to as a scalene triangle. Why don't you go ahead and flip over, and we'll finish this thing up. All right, for example 2, it looks like we're going to be classifying, once again, you're naming or identifying the triangles, but specifically by their side lengths. We're not focusing on angles, we're focused purely on sides. Why don't you go ahead and pause here and try these three examples and see how you do. And then when you're ready, hit play once again, and let's check our answers. Welcome back. All right, here we go. Triangle EGF. Where are you? Triangle EGF. If I were to draw that one separately just to get a better idea, it looks a little something like this, where I've got a single dash, and then a double dash, just like that. I see two sides that are the same, and therefore I'm going to call this an isosceles triangle. Triangle DEF. Where are you? D through E and then through F. Drawing that one separately. Looks a little something like this, where we have one side with two dashes, one side with one, and then one side that's just purely listed with a 14. Now, if you focus in on the picture over here, this is an important piece, is that the single dash side is a length of 13, which means that I could actually substitute that value right over here as well. And the double dash side is a length of 20, which means I could put that over here. So our current triangle of DEF has lengths of 14, 13, and 20, all three of which are different, which means that I'm dealing with a scalene triangle. Last one for example 2. Triangle DFG. D to F to G. So this would be the large outer triangle. If I draw that one separately, well, what the heck? Let's just do it right over here in the picture. There's a length of 20 for this side, another length of 20 for this side, And then if I want to determine exactly how large that side is, I can simply add up 13 plus 14, which comes out to 27, which is different than the other two sides, which means that I'm dealing with two sides that are equal, which means that once again we have an isosceles triangle. Next example. We're going to be classifying triangles by both angles and sides. So there's our difference. Is this time we're going to be doing both in that order, angles and then sides. Taking a look at example A, I'm going to first deal with angles, and here's my clue. I see that 90-degree angle right there, and I tell myself that it's going to be a right. And then I focus in on my sides, and I see 1, 2, 3 different sides of different lengths. Excuse me. So that means it's a right scalene triangle. And if you want to spell scalene correctly, you'll add in another E right there. Next up, looking at B, looking at my angles first, I see 60, 60, and 60, all three of which are the same, which means we get to write that really sweet word of equiangular, all three angles being equal. Then focusing in on the sides, we'll notice that we have three sides of 17, 17, and 17, all three of which are the same, which means it's also equilateral. Now that you have the rhythm, why don't you try C and D on your own real quick, give it a pause, and then check back. Once again, welcome back. Let's take a look at C here. We only have one angle that's provided, but that angle tells us a story. It's 130 degrees, which means it is an obtuse angle, so I can immediately classify the triangle in terms of its angles as obtuse. But then you want to focus in on the sides and see if you have any clues whatsoever. I'm looking at all three. I have no evidence of any of them being the same. Therefore, this is going to be an obtuse scalene triangle. Last one. We definitely have some clues to work with. When it comes to angles, I'm seeing 45, 45, and 90. The 90 is the one that's the giveaway. That tells us that this has to be referred to as a right triangle in terms of being classified by angles. But then when it comes to sides, I see 1, 2 sides that are equal. Therefore, it's going to be a right isosceles triangle. Home stretch. Last couple examples. Looking at example 4 here. This time we're going to be using the triangle classifications that are given to us to find missing side lengths. You'll notice that there's going to be a variable for this one, and you just want to use your clues, and by clues I mean single dashes or perhaps arcs for angles, to let you know how you can deal with these different expressions. I look at the spots where we have those expressions, and I see that there's a single dash and single dash, which indicates that those two items are equal to each other. And so now I'm basically looking at my equation right here. I'm going to rewrite it with a little bit more space as 5x minus 1 is equal to 4x plus 1. So now I have a classic algebraic equation, so I'm going to use my opposite moves to try to isolate that variable. I'm going to go ahead and subtract 4x from both sides, scratch, and now I'm left with 1x minus 1 is equal to 1. And at this point, I just want to get that x right there totally by itself, so I'm going to add 1 to both sides. Cancels. And I'm left with x equals 2. Now, taking a look at the directions up above, it doesn't just want us to get x. It wants us to find the side lengths. So now that I kind of have this intermediate answer of x equals 2, I know that I can return to the question up top, and I'm going to substitute that value right there for x. So this side would be 4 times the quantity of 2 plus 1. This shakes out to 8 plus 1, which equals a side length of 9. Now, this one right here also has a single dash, so I know it will also be a length of 9. And if you're feeling fancy, even though this also has a single dash, you can still substitute it in just to make yourself a little bit more confident in your answer. So we're going to do that. 5 times our value of 2 minus 1, 10 minus 1 also equals 9. Sliding over to our last question here. I could see students mixing this one up. If you just hurry too quickly, you might just see a triangle and there is an expression for each side. And you could make the mistake of perhaps setting this expression equal to this one. You have to pay attention to the clues. Our clue is right here. We have a single dash and a single dash, which means we're going to begin with these two expressions, and we'll get to this one in just a moment. These two sides are equal based on those markings, so I could go ahead and write 3x plus 4 is equal to the expression of x plus 6. Now I'm feeling good. We've got a nice algebraic setup here. We're going to go through the motions. We're going to subtract x from both sides. We're left with 2x plus 4 is equal to 6. Getting closer. We're going to subtract 4, subtract 4. We're left with 2 times something called x is equal to 2. And after dividing by 2, that something, that unknown, must be equal to 1. Remember, that's not a final answer, so don't stop there. Okay, we're almost home. The directions once again said find the side lengths, which means I'm going to go ahead and take my response of x equals 1, and I'm going to substitute that in to each value on each side. So this side would be 3 times 1 plus 4, which shakes out to 3 plus 4, also known as 7. I'm going to drop down here. I know that this side's supposed to be the same, so this would really be a place to check our answer. I'm going to substitute a 1 plus 6, 1 plus 6, also 7. Feeling good. Final thing, we're supposed to find all sides, so I'm going to go over to this one right here. 2 times the value that we found, which was 1, plus 2 more. This is 2 plus 2, which shakes out to 4. Well, thanks for watching. I hope you got all your notes down real nice. Oh, wait a sec. There's more. I'm going to go ahead and flip over. Can't forget about example 5. Man, how could I forget that? Example 5. This is a worthwhile discussion, and I know that all the geometry teachers, we're going to be checking on this when we return on Wednesday. This one's asking you to draw triangles after being given certain classifications. So notice the highlighted directions here. We're supposed to draw an example of each type, but if you find that it's actually not possible to do that, we just want you to explain why. Now, just a word of advice, there is at least one option in here that can't be drawn, so we want to make sure that you go ahead and give it a shot. Try to draw those examples if possible, and if not, please do explain why. We'll make sure that we check that when we return on Wednesday. Now, once that example's done, don't forget that you do have a homework assignment for tonight. If I were you, I would make sure that I try to finish this up in class, and then anything left over would transfer over to this evening. The assignment's right here on that new calendar that's been passed out to you. We're looking at page 219, numbers 3 through 10, 18, 19, and 23 through 29. So good luck with that homework assignment, and we look forward to seeing you guys back on Wednesday.